Here comes Speed Racer, he's a demon on wheels. He's a demon and he's gonna be chasing after someone.
All right, welcome to my embedded systems project. I am Team Speed Racer, and my project name is The Creeping Drag, which is a play on the words of one of the cars in Speed Racer, the Shooting Star. So the Creeping Drag seems a bit more apropos for my car. Here's my car. There is a lot of wires on here. I think I've pretty much used up every bit of space on the chassis to include everything. Small walk through here. Basically, I have a micro SD card on there. Got an LCD screen. I've got a Class D amplifier, which powers a 3-inch 4-ohm speaker, because we have a radio on here. I needed an extra battery pack to power the Adafruit motor hat, and underneath there we have a Arduino Mega R3, because we obviously needed a whole lot more inputs. Got some nice wheels. Underneath there we've got 4 DC motors, 2 in the front, 2 in the back. Got a servo motor, which allows the ultrasonic sensor to rotate when needed. In this mess here, I also have 3 buttons, all of them working as interrupts. One button turns the radio on and off. Another button changes the LCD screen temperature reading from Fahrenheit to Celsius and back and back. And the middle button turns the car on and off. I've got a photoresistor in there, which controls the lights on the front of the car. And buried in there, I've also got, you can't really see it. Oh, there it is in the middle there. I have a thermistor, which reads the temperature, and then will get displayed here on the screen. So that so far is what we have. Right now it's connected to my computer. I've powered off the wheels so I can also take us through a little bit more of the features of the car without worrying about it driving off. Normally it does operate, instead of on the USB cord, it will operate from a 9-volt battery, which gets attached here. So far, there's the overview, and now we'll take you through a couple parts of it. All right, now that we've walked you through just a basic overview, let's dive into a couple things here. We have a couple buttons here. Button number 2 basically turns the car on, and I grabbed a sound effect for that of a Camaro starting. So let's go ahead and start our car on up. So we can hear our car starting, and at that moment we also start to display our temperature. The temperature reading, I've got another thermometer back here, is fairly accurate. Off by 2 there, now by 1. The temperature reading itself is taken every 2 seconds, because on the car starting, I've got a function car start, and it sets timer 4 to interrupt every 2 seconds. So every 2 seconds, the thermometer is being read, and also the photoresistor, which will turn on the lights, we'll get to that in a second, is set there. I use for computing the temperature off that thermistor, we do use the Steinhardt conversions for there. Another fun part to it is that when I hit button 3, I can change to Celsius. And there we go, 24 degrees Celsius back here. And of course I can change it back to Fahrenheit. So that's the first part. We got the car starting and the thermostat, or thermometer if you will, being set. Now let's dive into the audio part of this. This was just kind of a fun feature I threw in. If we hit button 1, I've got a playlist of about 6 songs here. And it'll play a random one. It grabs a random number and picks one of those songs. So let's see what happens here when I hit button 1. No, really. There we go. Up comes the Nupsy Nups song New Thing. I can turn that off. Hopefully we get another song. Here's the screen. And then I can search for another random song. Alright, little death metal. Opus, Harlequin Forest. We turn it off. Clears the screen. Like I said, it was random, so plays again. There we go. Pain Cannot Erase by Steven Wilson. Cool. Turn that off. Grab another one. Rival Sons, Electric Man. Here we get Spirit of Radio, Rush. Seemed apropos for the car. So those are a couple of the functions there. You can turn that off. Another thing that it does is we do have that photoresistor buried in there, and it controls the lights. I'm going to go ahead and cover that, and you can see that the lights turn on. Take my hand away, lights turn off. Get a better view. Cover it up, lights turn on. Take it off, lights turn off. So those are some things, some more features there that are going on. All right, so back at the car, and I want to show you the driving capabilities of it. I've currently disabled the wheels at the moment. I want to show you how some of this works. I've uploaded it to, and I've also got a serial monitor that I'll open up to kind of show what's going on. We'll go ahead and start the car up. Got the sound there again. Temperature comes on, and once I engage the wheels, the car will just start moving forward at this point. At this point, it'll start looking for things in its path using this ultrasonic sensor. I've set it for 25 centimeters. So when something in its path is within 25 centimeters, it's going to look for a path around it. So what we do is if we move our hand in and we start to reach 25 centimeters, there I was, it looks for both ways to go around. Okay. So again, so you can kind of see my hand as it moves in. There we go. It starts to look around. And it chooses which way to go. And up here on the serial monitor, I can show you that as I move in, it says at 22 centimeters, it measures the right distance at 112 and the left distance at 83 centimeters. So since the right distance has more clearance, the car will choose to go right. Again, I move my hand in, gets to 23, calculates those distances, and again, it's going to go right. Mainly because my computer screen's in the way to do that. So what we'll do is I'll move on in, checks, same thing, I'll fix that again. Measured the same distance. And there we can have it go left. So that seems to function pretty well. The initial part that it does is once it senses the 25 centimeters, that the object 25 centimeters or less, it does back up first, then reads the distance to the left and to the right. The reason I have it back up is just because the car is a little wide and the turning ratio is a little bit, it's not a tight turning ratio. So in the future, I might make a car that's a little thinner. So those are the features, at least now on the desk, and I think we need to take it for a little test ride. All right, here we are outside. We're going to turn the car on, see if it starts to avoid obstacles in its way. Car's on, and it's going to start moving forward. As it moves forward, we'll stick some objects in the way. Simple box, it backs up, looks left and right, and decides to go left. We now are going to put down 2 boxes. Backs up, checks right, checks left, and decides to go right. We'll put those 2 boxes back down in front. This time, a little opposite. It backs up, checks left and right, and decides to go left. So it seems to be working pretty well. So I think we have a successful test out here. Cool. So that brings us to the end of my presentation. Thanks for watching. I had a ton of fun making it, designing it, coding it. It certainly was a challenge, and it's a class that I've really looked forward to since 2018. And finally, I was able to build my autonomous car. Again, thanks for watching. We'll talk to you later.
Here comes Speed Racer, he's a demon on wheels. He's a demon and he's gonna be chasing after someone. He's gaining on you, so you better look alive. He's busy revving up the powerful Mach 5.